Team PhysiotherAPPy, and today we're going to talk about the project we've been working on this semester, and we're very proud of it. But first, I'm going to introduce the team. My name's Catherine Davis. The keyboard, we have Kavila Krishnan, and then Alice Davis, Patrick Sheehan, and Jacob Heil. We'd also like to thank our TA, Dr. Hammond, our professor, Dr. Hammond, our TA, Cassandra, and our mentor, Josh, for all their help. So did you know up to 63% of patients in physical therapy don't complete their prescribed exercises, and around 20% don't do them at all? This is obviously a big problem because when people don't do what the doctors tell them to do, they're probably not going to get better and they may get even worse. Some background on this problem, why it happens, there are several reasons and maybe even more. First of all, physical therapy is very expensive. The APTA estimates that it's around $600 a month. It's also very time consuming, especially nowadays when people just want to do everything remotely and they have busy schedules. And this is probably why patient compliance is very low, although then that makes the process even longer. And then transportation to and from appointments to do physical therapy is itself very expensive and time consuming. So there are several solutions in place to try to fix this problem of motivation. The first one we're going to talk about was Be Well. It's a mobile app in the early 2000s that takes in certain factors of lifestyle and determines health from them. So you tell it how much sleep you're getting, how much exercise you're getting, your socialization, and it uses an algorithm to determine how that's affecting your mental and physical health. And while that is very cool, there are no external components to the system. It's all mobile and it's all user input, like most health apps on the market. The next one on the other end of the spectrum is TheraNetwork, and that was a knee rehabilitation program that uses a knee brace. And while you're exercising, the wearable determines certain factors about the exercise and it returns that information to the doctor. And because that's a little more automated, you're not really communicating with the doctor, he's just getting the information. They also have a motivational system where you can get in contact with other patients, but it doesn't have a mobile system like ours does. So the most important prior work to our project is KinoHaptics. It kind of formed the foundation of what we wanted to do. KinoHaptics is a previous capstone project, and they created a wearable, which is an armband with vibration feedback that works with a Kinect motion tracking and also a desktop and client for both patients and physicians. So people perform the exercises that have been set in the physician client using the patient client. And then as they're performing the exercises and the Kinect model follows them, the wearable gives them feedback about the exercises through vibrations. There are many changes we made to this. We added the app, which is what Patrick will talk about, but also we improved this code. We moved it from Windows 8 to Windows 10, which was actually a bigger move than you might think. And we also added more functionality and improved the wearable greatly, which Alex will talk about, and improved the way it stored data, which Jacob will talk about. So I've just talked about a lot of solutions. There are many more than just those three. Why is our app unique? The first reason is our exercise model. In KinoHaptics and in other technologies, the exercise model is very rigid and it's not very intuitive. So what we wanted to do is improve that so it's easier to use and more flexible for more exercises. The second thing is confidentiality. Not a lot of these apps have a very clear channel of communication. You don't really know where your data is going or what your data even is. So ours is a private chat system and also the encryption, AES encryption that comes with iPhone applications. And then finally, we wanted to make this as user-centric as possible because this is all about improving the quality of life of our users. So the app design is very sleek, it's very simple, and we also had continuous user feedback through the development of the project. Finally, I'd like to talk about some ethical concerns that we've addressed. The first one is, again, confidentiality between the doctor and patient, which we feel we have achieved through encryption and the secure communication between the two. The second one is safety, because safety is important in any project like this where people are involved, but it's especially important when those people are injured. We don't want them to get hurt even more. And we do that by having the physicians set the exercises very specifically so that the patients aren't going past their thresholds. And finally, the whole aim, as I said, is to improve quality of life. And we really do feel that our app has achieved that by making a time and cost-effective means of completing physical therapy. And I'm going to pass it over to Patrick to talk about the implementation of what we've been working on.
All right. More specifically, I'm going to tell you a little bit about the vision of physiotherapy and what the app itself brings to the table. First and foremost, we want to be able to let the patients do their exercises at home, but have them monitored in a way that helps them ensure a smoother recovery and a more monitored recovery by the doctor. With the direct communication that doctors and patients are able to have with our secure messaging system, doctors can track the patient's progress, patients can ask questions to the doctors, and so on. So here's a short little visual to explain what our work included this semester, building upon the KinoHaptic system, which involved improving the KinoHaptic feedback armband and the Windows desktop client. And then our addition was a mobile app, currently for iOS, that is built for the doctor and the patient to interact with the system. And of course, in the future, we want this to expand to all platforms. This will make it more accessible and thereby more cost-effective. I'm going to talk about some of the standards and difficulties that we encountered throughout the progression of this project. Dealing with legacy code poses issues, and it takes it proved for difficulties, especially like they were saying with equipment availability. We needed some extra steps to update to new operating systems, incorporate library updates, stuff like that. Having so many components in our system prompted a lot of work needed to bridge the gaps between systems. So all of us had to work together and standardize how the communication would talk between software and hardware components. Now I'm going to talk a little bit about the development method that we employed. It's called a dynamic systems development method. This involved a substantial amount of research before actually beginning the project into prior works like Catherine was talking about earlier. This gave us some insight into the field, what's out there already, what has yet to be done, what problems we could fix, etc. This is followed by an iterative cycle of user-driven development where we would talk to patients and doctors alike to guide the development of the app to make it as user-friendly as possible.
In order to decide what features would be relevant to our application, like Patrick said, we did continually get input from users. Over the course of our sort of beginning stages, we interviewed about 13 people, all who were 18 years old, and they were chosen because they fell into one of two of our user categories. They either would use our application in capacity as a patient, or they would fall into the healthcare provider, which, when I say that, I mean physicians or physical therapists. So again, basically, if you're going to use our app, you're going to be either like Mr. Jones, who is a patient and he hurt his arm and he requires some minor physical therapy. It's nothing too intense. It's not a major injury. It's a small injury that will require a short time duration of physical therapy. But the problem is he doesn't have time to make multiple follow-up appointments with his doctor. And the healthcare provider is either a doctor or physical therapist that just wants to help Mr. Jones get better, but again, they don't know if Mr. Jones is listening to him. So when we interviewed people who fell into the patient category, the top 3 things that they kind of said would be important is that they wanted that armband to be comfortable and intuitive to use. A lot of people were concerned with whether it would fit different body types, and it was just one of the biggest pieces of feedback we got. Another thing was that most patients wanted to be able to directly speak with their doctor. They wanted some way to message or text or whatever it is. And third, they wanted some flexibility in their exercise models. If they wanted to pause or play, or like during the course of a regimen, they wanted to be able to do those things. With the doctors, again, they were saying that communication with the patients would be very useful to them. They were also concerned with whether or not our application would make sure patients would be safe. And then the third thing was they wanted to make sure patients would be motivated to stick with their regimens. A lot of times, the reasons patients stopped doing what they wanted to do, doing their prescribed therapies, is they just didn't care to continue. So right here, we just sort of have like the top 7 features that the people we interviewed said would be important. Highlighted in blue are the ones we decided to focus on for the course of this project, which again, like I said on the previous slides, was direct communications between doctors and patients, the shape of the armband, and then the third thing was to improve accountability. Basically, this is just a way for doctors to be able to check that their patients are doing what they need to do. After we did do all our user interviews, we were sort of able to consolidate all the ideas into 3 major goals. We wanted to be able to facilitate communication between doctors and patients. We wanted to improve their accountability, and we wanted to make sure our product would be usable. And we said that if we could accomplish these 3 things, then hopefully it would increase the rate of recovery for patients, lower the cost of physical therapy overall, and improve patient compliance.
I'd like to talk a little bit about the system framework from a high-level perspective, and then I'll go into detail about the doctor's client. So as we've already touched on, the haptic system, which already existed, here's some arrows to kind of indicate the communication that goes back and forth. Some of this is Bluetooth communication, like between the armband and the client. The Connect, of course, has a wired connection, and these all serve as a way for the patient to interact with the system. And what I'll go into detail about is the client that the doctor and the patient are both able to use on an iOS app, and how that stores information on the server, which Jacob will tell you about shortly. So the doctor client, it's responsible for several things. One of the most important, thanks to our user feedback, we know that being able to communicate with their patients is a essential feature. Being able to view their progress, sort of a logbook of what their patient has done so far, is also accessible to the doctor, and they can of course prescribe new exercises to their patients conveniently from the app, which is a great improvement on the method before, which involved a rigid kind of goofy text string to create new exercises and assign them. Here's some views of the doctor's client, just to give you a visual. When they first log in and are brought to a profile page, they can see a list of their patients, and from there click and go check their progress and do any of the things I was discussing earlier. There are several selectors like this to describe the type of exercise that the doctor would like to create. What we have so far in the exercise model that we built is a selection of a joint, a movement type, and a cardinal plane. So for example, as you will see in a video, you might choose the left shoulder as your joint. The movement type is abduction or adduction, and you can specify the cardinal plane. For example, there's frontal, bisects, front and back, and transverse from left and right. Those types of details are expansions we made to the exercise model. And on the right is just the view of what the doctor would see when creating it.
For our database, we have a basic LAMP stack, the Linux OS, using Apache to host MySQL server that is communicated with a PHP API. And we chose MySQL because of its ubiquity and its relational mechanisms that allow us to sort through the various information that we hold on the server, which includes user information, exercise information, and messaging. Now, we're going to move away from the application and how it interacts with the patient in the cloud and move down to the haptic system and how we augmented it, and what the Connect, the haptic feedback device, the console, and the patient do to interact with each other. So the Connect provides a system to track various points on the human body. It provides a skeleton that we send location data to the computer with when we keep track of them. And as we'll see on the next slide, they have a visual representation of their movement as they perform these actions. And this is done with Unity 3D, which porting the Windows 8 Connect communication with Unity 3D to Windows 10 caused a variety of problems, which was one of our major blockades in the completion of our project. And the data that the computer receives is point data, which can take 3 points on the body from the skeleton provided by the Connect, and calculates the angle with a simple arc cosine to this equation to decide when they have reached a particular point that they were supposed to through the exercise prescribed by the doctor. Now I'll hand it over to Alex to explain the haptic device.
Okay, so this is a picture of our armband. As you can see, it's much more comfortable than the one shown above. It's much more pleasing to the eye. We also we continued the vibration feedback and improved that. I'll explain that on the next slide. And we supported the XY directional guidance with it, and it's resizable for all those different people's sizes, arms, and so this is the internals of our armband. We have a teensy microcontroller and the Bluetooth module, which is shown in that top picture, and then the vibration motors on the inside. Each one of these vibration motors can be moved along this black strip here to be put in the correct spot on anybody's arm, and they are controlled individually. So these two are controlled by themselves, like you can control these two, the two on the ends, and these two in the middle separately. This allows us to be able to give that directional guidance I spoke about. Okay, so we just talked about this system. Now we're going to go talk about the patient and what they see whenever they're using the application. So in the patient client, we have the ability to communicate with the doctor. We have the exercise information that they've been given, so they can see a list of all those exercises they're supposed to do, and it'll also update with the tracking of the repetitions that they've completed on the Connect. This is a picture of what they see when they log in. So you can see here on the left picture that they have the different prescribed exercises, and then they will see this screen once they click on one of those. They can see here that this is like a demo of what they're supposed to do. It shows them that they're doing an arm raise here. And then when they click complete exercise, all they have to do is go to their computer, run the program, and then log in, and it will start their exercise that they picked. This is a picture of the messaging client. So they have their different people they're talking to, and then here they can send messages back and forth.
And then what we have here is a small subset of our project video. This is just showing the functionality of the app. The audio is not very good here, so I'm just going to narrate over it. If it'll play.
But the already started.
We
already started over.
This is the doctor client that you're going to see first. The doctor logs in, they can view a list of patients, they can view the patient exercises and the corresponding video from Haptics, and then they can set new exercises by joint type, movement type, and according to the cardinal plane, and then they can save those exercises and the number of repetitions for their patients. The patients log in and they see a list of the exercises that have been prescribed, and then instructions and the corresponding Haptics video, and then once they complete the exercises, they return. This is the armband that Alex talked about. You can see all the stuff inside. It's also got cotton padding, so it's very comfortable. There's the battery pack that's attached, and then it fits many arm sizes comfortably. And here's Patrick using the technology itself. He's got the armband and he's getting vibration feedback from it as he completes the exercises. And then Haptics is registering that he's completing them and showing his progress on the screen as the model follows him. And finally, there is messaging between both. That's a list of people this person can message, and then the message history, and they're going to send a message to talk to their doctor, ask questions, become motivated, anything they need, really. And that's the app in action.
So after we were able to complete all of those things, we decided to test our product with some post-development user testing. We completed 20 user studies. Most of them, actually all of them, were students on campus, so we weren't able to do post-development testing with people who fell into the healthcare provider category. But overall, this was our feedback that you can see. Most people were really happy with the wearable. They liked the way it looked. They said it was comfortable. It fit many different arm sizes. When people were run through the app, they found it to be really easy to use. They liked the way it worked. It was intuitive. No one really needed some explicit instructions. After the study was completed, there was a post-study questionnaire where about 10 to 12 different features of our application were listed, and users were asked to rate each feature on a scale of 1 to 10. So the aggregate components all were rated at 86.7% satisfactory. And their overall just experience with the entire system, 93.5% satisfaction was what we got. So after having completed all of that and user studies, we are able to kind of say that we did achieve some of the goals we set out at the start of this project. Our app is user-friendly, easy to use, intuitive. The armband, again, people were really happy with it and found it to be comfortable and simple to use. We improved accountability because doctors can see whether their patients have done their exercises and the correct amount of repetitions. And we were able to, like Patrick showed you, generate a generalized exercise model.
So the future work on the app, we really want to improve motivation because that is, as we said, a big deal. It's a big deal on all of these projects. So we want to incentivize people to do their exercises in certain ways. We also want to make this multi-platform, as Patrick touched on. A lot of people don't have an iPhone, and we also want them to be able to do it on tablet or mobile. We would like to support more exercises and types of feedback. We've expanded the exercise model, and it is there. It's ready to use. We just need to implement it. The same is true for some of the directional capabilities of the armband. The hardware is all in place. And finally, we would really like to get some studies with patients using the app and also with doctors, which we weren't able to do in the time frame, but we feel like we could get even more valuable feedback from that. This was our team. There's Patrick. He was our leadership and front-end development. He has a lot of iOS experience. Myself, I worked on security and doing a lot of the research and paperwork for the team. Alex completely did the wearable, did a great job there, and Jacob completely did the back end in the same vein. Kavila also worked on front-end development and a lot of the presentations we did. We'd also like to thank several individuals. First of all, our mentor, Vijay. He was super helpful with working with the Kino haptics, as he'd worked on that in the past. We also had an anonymous physical therapy assistant help us at the beginning to kind of determine what our goals needed to be, and that was indispensable. We met Eric and Whitney from ISRI, who gave us a lot of feedback on our initial presentation and showed us where we can improve it. And then Nick, a classmate of ours, who helped us with the Bluetooth connections as we moved from Windows 8 to Windows 10. That is everything. Do you have any questions?
Yeah, just can you go back to user studies slides? So what's the difference between aggregate of components rated at 86.7 and then overall experience rated at?
So we did user studies throughout, and we had 10 separate features because, you know, there's Kino haptics, there's the wearable, there's the client on the desktop, there's the physician client, there's the app, and the many different features of the app. We had them rate each of those independently, and that also, the scores really depended on how far we were in the project. So when we just took all of those and averaged them together, that's what everything got, because some things some people didn't like. But then when they did say, the second score is what they were happy with overall, like their experience in the study.
Thank you all for coming.
Yeah, I mean, since I'm aware of like the whole work, I don't have questions. Just